We're going to have our junior high class in here, our senior high class in here, our college career class in here, and adults in here. So we're all in here today. Let's move up front. Guys, move up front. Come on up. Come on up. Okay, good morning, everyone. If you weren't here for first service, we are privileged today to have our senior high camp speakers come and join us. And so they are Dr. Ray Bohlin over here, and his lovely wife Sue over here. And so we'll give them a great big hand. So they're joining us for a CBM camp, and we're really excited to have them. They're with an organization called probe.org, and if you ever want to check out the website, great resource. Your pastors have used this for many years, the resources and stuff, and they are coming to speak at our camps. But if you look at the website, there's a lot of topics from world religions to apologetical questions to current trends and current issues that are being brought up. And so this is a great forum for you, for everyone to ask questions, because Ray and Sue are great resources to go to, because we always look at the website for resources, and now we have them in person, so we can ask them questions like that in person. So what we're going to do is we're just going to leave it up to you guys to ask whatever questions that you want. It can be, this morning we talked about biology and how it points toward the existence of God and who God is and how we can believe the scriptures. And but you can ask, I think you can ask other questions. Mm-hmm.
The best thing would be for them to know about science and faith or creation and evolution.
Okay.
That would be the best place to narrow down.
Okay, if we want to focus on creation evolution questions today. And I know a lot of our kids have a lot of the questions about that because you get that in your science classes and stuff. So don't be shy to ask some questions. If you would rather write it down on a piece of paper, maybe I'll get some paper for you guys to do so. But Frank is going to go around, and he's going to have this microphone, and so you can just raise your hand. And if you have a question, you can say it into the microphone. Dr. Ray is all mic'd up, and so he can answer your questions like that. But when you use the microphone, just bring the mic close to your mouth so we can hear you, okay?
Let me just say that for the benefit of those who weren't here in the first service, I'm going to play a couple of very short videos that describe some of the things I was talking about to kind of get your brains working a little bit on the direction I'm going to go. And this first one is a video that was an basically a promo piece for the book Signature in the Cell, which was released in 2009. And it was a discussion from an intelligent design point of view how life itself could not have originated by chemistry alone. It required intelligent input. Now, they're going to be showing some molecules. They're going to be showing you some DNA, some RNA. And I want to try put this in perspective for you. If you know what a millimeter is, right? Well, the molecules you're going to be seeing are 1,000,000 times smaller than a millimeter. So take a millimeter and divide it up into 1,000,000 slots. And what we're talking about is one of those slots. The width of these molecules is one of those slots. So just to try to help you get how small this stuff really is. So here we go.
In 1957, Francis Crick first proposed that chemicals called bases along the spine of the DNA molecule function as alphabetic characters in a written language or digital characters in a machine code. This animation shows how this digital information directs protein synthesis. First, a large protein complex separates the tightly wound strands of the DNA to prepare it to be copied. During this process of transcription, a protein complex called a polymerase produces a single-stranded copy of the original instructions. Here we see this copy, a messenger RNA molecule, being constructed inside the polymerase as individual bases are positioned and added to the growing strand. Now we see the polymerase in action from the outside as it spits out the messenger RNA transcript. Next, this RNA transcript approaches and passes through a molecular machine called the nuclear pore complex, an information recognition device that controls the flow of information in and out of the cell's nucleus. Now we see the genetic assembly instructions on the messenger RNA approaching and arriving at a two-part chemical factory called a ribosome, the site of protein synthesis. As the messenger RNA transcript passes through the ribosome, the process of translation begins. During translation, a mechanical assembly line builds a specifically sequenced chain of amino acids in accord with the instructions on the transcript. These amino acids are transported from other parts of the cell by molecules called transfer RNAs, which link specific sequences of bases to corresponding amino acids. The sequential arrangement of the amino acids determines the type of protein constructed. When the construction of the chain is complete, it is transported to a barrel-shaped machine that helps fold it into the precise shape required to perform its function. After the chain is folded into a protein, it is released into the outer cytoplasm to do its job in the cell.
Highly recommend this book. Highly, highly recommend it. And what you saw is just a sliver of the information content in the cell. So what I'm going to show you now is I had this ready to go in the first session, but we just didn't have time to do it. This is Big Dog. And Big Dog was created by Boston Dynamics on a contract from the United States Defense Department. They wanted to create a mechanical mule, if you will. And so this video is going to show you some of the things that Big Dog was capable of doing, and I'll just add at the start that this is run by a computer that's carried on the machine itself. It's powered by a one-cylinder gasoline motor, so that the buzzing you're hearing is the motor operating in the background. And each of its joints, each of its limbs, if you will, is reporting back to the computer 500 times per second. All of its information, where it is, the load it's bearing, all kinds of stuff, 500 times per second. And so let's just watch what Big Dog can do. There we go. pretty amazing machine. Is there any question in your mind that Big Dog is designed? It's not a chance assemblage of parts, right? But somehow when we look to a biological dog, well, all of a sudden that's different. But a biological dog, I've got one at home, a 4-year-old golden retriever. His name is Baylor. And in his snout is far more sensitivity than anything we can dream of in our own nose. And besides, the biological dogs do something that the engineers would just throw up their hands and say it can't be done. Let's just say the Defense Department came to Boston Dynamics. They have one more parameter that they want Big Dog to be able to do. We want you to design 2 slightly different types of Big Dog. And when the 2 actually come in close proximity to each other, something is exchanged from one to the other such that a tiny little Big Dog is created in the one and it grows its own new Big Dog. We want our Big Dogs to reproduce. Sorry, no, we're not even going to try to do that one. It just ain't going to happen. But the biological organisms do that all the time. It's quite natural. It's quite plain. It's quite evident to them. So I've given you example molecularly of designing the cell. I've given you one more analogy about some of this. So now it's your turn. I'm going to stop presenting, and you can start asking. Don't be shy. I won't bite.
What does the Defense Department use this machine for? And how much did it cost to produce it?
How much did it cost? Wow, I don't have an answer to the cost issue, but what the initial design parameter was, as I said, to try to create a mechanical pack mule. If all you had to do was carry a little bit of gasoline as opposed to feed and fodder and all kinds of things to take care of a biological animal, and as you saw the payload, Big Dog was able to carry about 30% more than its own weight. Now a human, I've backpacked before, and I'm about 175. You put 50 pounds on my back, and I'm like that. If you put 200 pounds on my back, I ain't going to do it. I'm not even going to get my feet. I'm not going to take one step. So there's an advantage in power. There's an advantage in payload. There's an advantage in the fuel that it requires and how much you get from that fuel. The amount of heat that's generated by the explosion of gasoline is huge, far bigger than anything else we've been able to come up with. That's why we use it in our vehicles. So it's designed to, behind enemy lines, they'd have to quiet the motor somehow, but something they wouldn't have to feed quite so much and could carry far more than any other biological animal could. I'm guessing that Big Dog's a $100+ million project, if probably several hundreds of millions.
For those of you that don't know, Big Dog became a local company. Google bought this company in December of 2013. They didn't say how much they paid for it, so you can go find a Google employee and maybe they will tell you.
It's a Google company. I'm sorry, that's just sad. I hope there's no Google employees here, but
how come that ant is so big?
How come what?
The ant.
Oh, the dog?
Oh, I thought it was the ant. Sorry.
Well, it's mechanical, so it's really neither one. It's that size to be able to carry sufficient payload that the military was looking for. So if it was just able to carry, 20, 30 pounds, that's because a human can carry that much on their own. They needed something that was going to carry hundreds of pounds of equipment and material.
Good morning, Dr. Ray. I guess you talked a lot about intelligent design. Are there any examples in nature of the opposite, of maybe random design, chaotic design? For example, the existence of a tailbone in people. And I also work in the medical field, and I get a lot of women who have told me, who would design women so that they put the bladder under the uterus that makes them have to go to the bathroom so often when they're pregnant. So something like that. Can you speak to unintelligent or random design?
Well, you know, what you will find, it's a good question. You know, what examples are there of what we would see as counterintuitive design? And yeah, there are examples of that. At least on the beginning side, when we look at it initially, it looks a little confusing. Why would it work out this way? What we often forget is that when you're creating something new, if you're a computer engineer or a mechanical engineer, an electrical engineer, with the systems you're working with the power source you have available to you, there are always design constraints. For instance, when they first came out with laptop computers decades ago, they couldn't perform anywhere near what a desktop could because there was no size limits on the desktop. In order to make the laptop available and useful, it had to be smaller, you had to compact it, you had to have a screen attached to it, you needed a way to fit a lot of stuff that took up a lot of space in the desktop computer and squeeze it into the space of a laptop. That also meant, by doing that, at least initially, it just wasn't as powerful. So you have limitations when to design when your goals can sometimes be competing end goals, like you mentioned for the woman with the bladder's placement and where the baby's carried. If you put in all the other design parameters, that likely is the most efficient design for what you're trying to achieve, and that's often what we don't really catch. I can't give you a lot of the specifics, but in our eyes, for instance, the nerve cells that carry the transmission from the rods and cones, which are at the back of your eye. They're at the back of your eye. But the nerve cells that transmit a lot of that are in front of them. So the light is actually passing through around some of the nerve cells and then being picked up by the rods and cones to transmit the electrical signals. But as it turns, that seems backwards. Wouldn't you want to put the nerve cells behind? But it turns out that the blood flow is such within the eye that the only way to have sufficient blood flow to those nerve cells is to have them in that configuration, not the other. And the eye has other aspects on the inside that focus the light accurately so that you're not seeing a fuzzy image because of diffracted light from the nerve cells. So, yeah, on initial looking at it, it doesn't look well designed. It looks a little sloppy. But then when you investigate further and you're aware now of all the design features that are here, it suddenly makes perfect sense.
Let me just say, I have permission from Ray to jump in.
During the week, especially.
Yeah.
I have made the observation for years that I think one of the reasons that God gives women bladders that are smaller than men's in the location where they are is to teach men to be patient and gracious and thoughtful. You know, think road trips. You know, so Dad gets behind the wheel of the car and says, "We're only going to stop to go to the bathroom when we're putting fuel in the car, so nobody drink anything." Nah, that doesn't work so well. It's a character development issue.
And we probably don't have to add that there are plenty of issues with men that help women develop patience, and it goes both ways.
Yeah, I have a question. Do you consider evolution as unintelligent design? As evolution as unintelligent design?
Do I consider evolution to be the designer's way?
No, unintelligent.
Oh, unintelligent. Oh, okay. Yes, absolutely. And that was Darwin's intent. If you go back and read just even a couple chapters of The Origin of Species, it's really primarily a theological argument against the Creator and against design. And Darwin was very insistent up until his deathbed, all the way through, that that descent with modification, his phrase, is undirected, unplanned, and without purpose. It just happens. It has to be just a natural process with no interference. So yeah, that was his entire intent. There's no intelligence needed or involved. So yeah, evolution is unintelligent design, yeah.
As we think about evangelizing our coworkers or people we run into at the store or wherever in the community, where does intelligent design fit into that conversation? Like we don't want to just convince someone that there's a God, because then they can be, they say, oh, Allah created this, and or some other God. So where do we fit intelligent design into our thinking of evangelism as we reach out to our neighbors, our coworkers, and such?
Well, it's a good question. To me, it fits into that category of the existence of God, and as Romans 1:20 indicates to us, that there are certain aspects of God's eternal power and his divine nature that we can discern from the creation. A presentation that I do frequently in various audiences, various groups, I draw several conclusions about that. When I finish on the origin of the universe, the fact that it couldn't have just happened by itself, then we see God is eternal. Something has to be eternal. If you think about that for a minute, you realize that if nothing has been eternal, then whatever is just came from nothing. Nobody's going to really accept that. So something has to have always been here. The Big Bang cosmology, the reason many in the scientific community were so bothered by that is because it indicated a beginning to the universe. They were hoping that the something that was eternal was the universe. So now they've discovered, and their own science demonstrates, no, the universe is not eternal. It had a beginning. But then you come back, well, something has to be, right? You already agreed to that. So what could that something be? It would have to be something that's not material, that's not the universe, that's not matter, that's not energy. You're talking about something spiritual, supernatural, immaterial, and that something has to be eternal. Well, you've just named a characteristic of God, the God of the Bible. He's eternal. When you look at the design, as we showed in the DNA, and the information that's required for a cell to operate, libraries and libraries and libraries of information in each individual cell, that requires intelligence. We've learned something else about the Creator. He's eternal. He's intelligent. One of the things I'll look at, and some of you here already, some of you have it to look forward to, but I talk about the design of the woodpecker, and that woodpeckers are strange creatures. You think you've got God all figured out, and he makes a woodpecker, and you say, "Man, what's going on here?" God's imaginative. So, with intelligent design, when we apply it to living things, particularly, we're able to see aspects of his eternality, his power. If the universe didn't exist and then it did, well, how much more power do you need for a God? There's nothing, and then there's everything, okay? So he's eternal, he's powerful, he's intelligent, he's creative and imaginative. All these things can be easily applied to the God of the Bible, but the God of pantheism, the God of Hinduism, the God of Buddhism, well, that's not a personal God at all. It's like the Force of Star Wars. It just kind of unites everything, and there's nothing personal about it. You can't say that Brahman is intelligent. Only people are intelligent. Only persons are intelligent. It's not creative. It's not powerful. It's not even eternal. What does that even mean? So the characteristics we glean from nature using intelligent design give us characteristics that are consistent with the God of the Bible. So that's where for me it would fit in. And then my question is, well, okay, if this God really exists, we know something about him here. Did he ever speak to us? Well, that's when you go, what does the Bible have to say? Why is that one the Word of God? Why not all the others? What does the Bible talk about? Oh, the major topic is Jesus Christ. Old Testament, New Testament, it's all pointing to Jesus. Let's talk about Jesus. So you go from the existence of God with characteristics that are consistent with the Bible to, okay, what is the Bible actually? Why do we trust it? Why do we believe it? And if we can believe the Bible, what's it about? Well, it's about the person of Christ. So it's your stepping stone. It's your starting point.
Here, which says, is the creation of the human body the most complicated? Then it ends. But I think the question is it the most complicated thing in the universe?
Is the human body designed? Yes, absolutely it is. And if you think about it, let's put it in a theological context. We are the only creature God created that bears his image. Now, it doesn't mean we look like God. You think of Michelangelo's painting of God and Adam in the ceiling of the Sistine Chapel, you know, God reaching out with the flowing gray hair and beard and buff body. And well, no, God doesn't look like that. Okay, we don't know it. He's spirit, okay? But we are in his image because of certain characteristics of who we are. We can create because we're in his image. We can speak intelligently because we're in his image. We can access the spiritual realm of the world because we're in his image. So God had to create a biological body that was able to fully express the image of God that he placed in us. That suddenly puts your entire biological system in a completely different context. And I even just spoke on this recently. Our intellect far outpaces anything else in the biological world. Our speech, we've tried to teach various forms of apes, gorilla chimpanzees, bonobo chimpanzees, we've tried to teach them human sign language because they don't have the equipment to talk like we do. They simply can't. And even with sign language, their signs are, 2 to 3 in a row is all they can do. They get to the point of about a 2.5-year child, and it takes intensive amounts of training, years to get them to that point, and then it just stops. But what linguistics people will tell you, real human language doesn't start until you're 3. When you really start applying the grammar, the syntax, before that you're developing vocabulary, and it's kind of awkward, but not until after 3 do you really start developing true human language. Well, the chimps never get there. They can't develop, they don't use human language. They can't do it. Their brains aren't sufficient. And even many of the signs they use are signs that they use in nature, out in the wild, but they've kind of adapted what they already do to what they were being taught, so it doesn't really matter. So our intellect, our language, the hand. This is an amazing instrument that we never think about. Chimps have an opposable thumb like we do, but they don't have the fine manipulation skills because their fingers are big and fat. They really can't hold and control a pencil. Some of them can type one finger like on a computer, but you're never going to teach a chimp the QWERTY system. No, they cannot do it. This hand allows us to manipulate and communicate and alter the world around us in a way that no other organism can. And our upright stance. Chimps can walk upright a little bit for a little while, but they kind of waddle, and it's very clumsy, very awkward. And they can't carry much because their arms have to extend, because their chest expands outward. Ours is nice and slim, so our hands can be right down here. We can run. Chimps can't run. They can't do. We can carry lots of things in our arms to build a fire, for instance. We can carry large pieces of wood because a self-sustaining fire has to be about half a meter in diameter. Chimps would not be able to gather enough big wood because you have to pick it up, carry it a distance. They can't do it. But fire, our mental ability and fire, our ability to control and use fire is what makes us absolutely unique in all the animal kingdom. Every other organism completely fears fire. We do too, but we've devised ways to use it. To cook our food, to provide light, to provide warmth. That's how we developed the use of metals, because you have to heat metals up to high temperatures. You couldn't do it unless you can build fire. So the ability to utilize metals comes from our ability to use fire. And our ability then to do chemistry comes from our ability to build fires. And therefore, our ability to have electricity is because we can utilize fire. No other organism God created can do that. Fire is absolutely amazing in our ability to use it. One thing we've discovered, by the way, your brain consumes about 20% of the calories you take in. It's always working, even if, as a guy, when somebody asks you, what are you doing, and you say, nothing. Well, your brain is still using 20% of your calories, okay, even if you're not thinking about anything. I do that frequently. I just ask them, what are you thinking? Nothing. It's just kind of the way it is. We're special that way, guys. We don't have to think about anything. But you're not really saving calories. Cooking food opens up certain plant and meat calories to us that we couldn't get unless it was cooked. From starches, for instance, potato and other starches, you get about 30% more calories from them if they're cooked. Meat, or just even an egg, if you cook an egg, you'll gain about 80% more energy than if you just drink it down raw. It transforms the molecules into things our system is much more readily able to use. So for instance, if you decide to do a raw food diet, you can take in just as many calories in a day as a person who's using cooked food, but you're probably only going to get about 60% of the calories from that food because your small intestine doesn't digest everything, and when it goes into the large intestine, guess what's in there? Bacteria that just use up all those calories for themselves, and they don't give it back. So when you go completely with raw food, yeah, technically the calories are there, but you're only getting you're barely getting a majority of them. That's why cooking our food, utilizing fire, what's that feed? It feeds the brain. Without cooking our food, our brain, there are some people who, they've done studies with some individuals who've gone through completely raw diet. And some women end up getting so malnourished that they stop menstruating. Okay, that tells you something's not right. So, yeah, a completely raw diet to lose some weight. Yeah, you'll lose some weight. No doubt about it. But you can't keep doing that forever. So yeah, our bodies are uniquely constructed in a way to perfectly house the image of God, and that means we are the most unique and complex organism on the earth. Long answer, short question.
I'd like to ask a question about theistic evolution.
Okay.
Two-part.
Yeah.
First is, did God use evolution in the creation process?
Mm-hmm.
And secondly, are the days in Genesis, do you believe, literal 24-hour days, or do they refer to long
question.
ages?
Always comes up. How long are the days? First of all, with theistic evolution, first of all, you have to be careful to define what do you mean by evolution. Because as a biologist, I've studied in the field, I've collected organisms, I've done genetics on populations. I've seen that populations of organisms, they change genetically over time. If you want to call that evolution, yeah, there's change over time. We see that consistently. We even see some examples where there seems to be a variant within the population that expands because the environment changed somewhat. They've got a slight advantage over everybody else. But the reality is, if you start with a fruit fly, you finish with a fruit fly. If you start with a peppered moth, you finish with a peppered moth. The variety was already there to start with. So when you say theistic evolution, what I assume you're meaning is the evolution from a single cell to human beings by a natural process. Did God use that process, or did he somehow superintend and guide it at steps along the way, causing certain mutations to come about, and therefore he's involved? It looks like a natural process, but God is working within it. I don't accept that hypothesis for both scientific and theological reasons. My study of evolution, particularly as a graduate student, showed me that evolution is consistently represented as an undirected, purposeless process that is purely natural and is actually quite wasteful and inefficient. The whole idea of the fit survive implies that the unfit don't. And there's no plan or purpose to it. Even most theistic evolutionists today from within the church, they're Christians, have been driven so far off the field that even they want to say, okay, it is a purely natural process, or else at least it looks that way. God is not intervening in any way that we can recognize, so it looks natural. My criticism there is to say, well, then how do we distinguish yourself from an atheistic evolutionist? Atheism uses that kind of evolution. Pantheism uses that kind of evolution as their origin story. If everything looks like it was a natural process, then what value does Romans 1:20 have? We're told that it's plain. It's evident from creation. We just have to look at it. We see the evidence of a creator. But if it all looks like a natural process, then I think we've all got lots of excuses. So there are theological, there are scientific problems with it. And I think a lot of those individuals have gotten themselves forced in a corner where somewhere early in their life, if they were scientists in their early years, and maybe they still teach, maybe they still do research, whatever, but this was a major struggle for them. What do I do with Genesis and with what I'm learning in my classes and so forth? How do I balance these two? Theistic evolution seemed like a good compromise where I could still be a full scientist and just talk about the same process as everybody else does, but when I'm in church with my friends, I can still say, no, God's creator, God brought all this about, and it's a system that allowed them to be not just comfortable, but to operate in both spheres. And so when people like me come along, and we start saying, no, evolution simply doesn't work, the theistic evolutionist gets extremely uncomfortable. And oftentimes, my most difficult audiences are not atheistic evolutionists, but theistic evolutionists, because suddenly there's so much more at stake for them. And they've made their categories, their work and life fits within it, and now I'm coming along and saying, no, you got to toss all that out. It's not biblical, it's not scientific. And they're very resistant to the process. And I can say that from over 40 years of experience. My most difficult conversations are with people like that. But yeah, I don't accept it theologically, I don't accept it scientifically. Now, the days. Day 1, day 2, day 3, day 4, day 5, day 6, God rests on the seventh day. I have a presentation that I do, and I'm going to use it as a part of the one of my workshops at the retreat this coming week on Christian views of science and earth history. I'll go into a lot more detail there, but I cover in general the three broad categories. What I would call literal or recent creationism, where all the days are literal 24-hour periods of time. They're consecutive. There's no gaps of time between. There's progressive creation that says, no, the days aren't 24 hours. They could be indefinite periods of time. And then there's theistic evolution, which we just talked about briefly. All Christians fall into one of those three broad general categories. Lots of finer points within those, but those are the three big categories. When it comes to the word day, what is often told us is that, well, the days, whenever we see in the rest of Old Testament where days are numbered, they seem to always refer to a 24-hour day. We have a description of each day as being evening and morning. First day, second day, third day. And the word for day itself, the Hebrew word that we transliterate to yom, can mean a number of different things. It can mean an indefinite period of time. The same word is used to say, the day of the Lord is upon us. Well, there it doesn't mean a 24-hour period of time. It's just a general time frame, okay? So it can mean a number of different things, but the ordinal sequence, 1, 2, 3, 1 through 6, and the evening and morning, those seem to, in the context, indicate 24-hour period. But there are some problems with that you end up with. Days 1, 2, and 3, there is no sun. Sun is created on the fourth day, but yet light's created on the first day. and we're given the impression that there's a rotation of the earth in reference to some source of light, but there's no sun, there's no stars yet. Are we in a literal account? When you get to the end of the creation account, it uses the same word day, yom, and basically, my Bible's sitting there somewhere, or is it in the, yeah. It's been a while since I've quoted it, so I don't want to mangle it too bad. Now, when you look at Genesis chapter 2, verse 4, it says, "This is the account of the heavens and the earth when they were created." That's the new NIV, New International Version. What it says in the NASB, which is a more literal word-for-word kind of translation, and this is the account of the heavens and the earth in the day that they were created. Now, it uses the same word, yom, but it's referring to 6 days, not 24 hours. So in the same passage, you have a use of the word day that's not literal. Also, all the other 6 days have an end. Remember, it says evening and morning. How much of a day is evening to morning? It's half a day. It's going from sunset to sunrise. It's not describing a 24-hour day. It's describing 12 hours. Also, each of those first 6 days has an end. God ends it. God rests on the seventh day. The account does not say the seventh day ends. Are we still in the seventh day? Could that be? You could just, it was assumed that the seventh day ended. Well, okay, but that's not in Scripture itself. That could seem like a reasonable conclusion, but it's not there. Basically, for me and Probe Ministries, because of me, we don't take a position on the age of the earth or the universe. For me, it's far too undecided. The data can fall different directions for different people. They look at different things. I can find large numbers of Old Testament evangelical scholars who know the Hebrew language, who know the other ancient Near Eastern creation accounts. They know how to compare them to Genesis, and they do not agree on how to interpret Genesis. And then I can gather a bunch of physical scientists, astronomers, geologists, chemists, and we can talk about all these dating methods and the aging thing, and I find evangelical physical scientists who understand all of the physics, geology, and the chemistry, and I can't get them to agree on how to interpret the scientific evidence. And that's when I throw up my hand and say, I'm a biologist. I don't have the training of either one of those groups. They can't make up their minds. I don't feel forced to make a decision on that. To me, the far more important question is that, an answer is that there is a creator God who is a super intellect, and he has left that mark in everything he's created. That we can all gather around and support each other and encourage each other and work together on that one project. And once we make some real headway with that, which there is some, in the dam of naturalistic evolution, scientific evolution, there are cracks, and it's leaking. And the cracks are getting bigger. And more water is coming through, and there are some who are saying 10, 20, 30 years, the dam may completely break. It will be untenable. It's looking that way. And once that's accomplished, then let's all get together and have a big discussion about how long it all took. But let's focus our attention here together.
Questions, but I don't know because of time if you'll be able to answer them. But you may have touched on this when you were talking about theistic evolution, but how does microevolution fit into intelligent design? For example, natural selection occurring on a small scale, like if you don't finish your antibiotic prescription and the bacteria become resistant or things like that. And then my other question is, how accurate is carbon dating? Because it seems like a lot of scientists like to use that to determine the age of the Earth when natural disasters happened, or the age of dinosaurs, things like that. And then, sorry, I have one more question. What are your thoughts on some of the historic archaeological sites, like the discovery of the supposed first human, Lucy, or other humans that were found that they aged to be thousands of years old or even older?
Okay, so microevolution first. I'm a big fan of microevolution. Microevolution happens. And what we're really meaning there is changes in which the organisms, the species, is able to adapt to minor change in its environment because it already has genetic variability that allows it to do that. The famous example is the peppered moth in England, that most of what collectors found were a white variety that had black and gray speckles on it. That's why it's called the peppered moth. But in their collection, there was always a form of the moth that was completely black. They called it a melanic form. Very, very rare, but it was always around. With the Industrial Revolution, with all kinds of pollution and smoke coming out, it turns out that the trees began to change because there used to be a lichen that grew on the trees that the peppered variety was very much camouflaged. Well, all the pollution and smoke started killing off all the lichen, so that the trees now were dark. And suddenly, that dark black form of the moth started increasing in its frequency. The environment changed slightly. For some reason, the darker moth had an advantage over the peppered one, and that's microevolution. We see those kinds of changes all the time. By the way, when London started cleaning up a bit and the pollution was a little bit less, the lichen started to grow back, and the moths responded. The dark melanic forms started to shrink in numbers in the population. The peppered moth made a big rebound. So that's clear environmental influence and change. Second question was, remind me again. Oh, carbon dating. What you're really referring to there is not just carbon dating, but radioactive dating in general. Carbon dating is one form, and carbon dating actually is quite limited. When you're talking about radioactive dating, what you have is when you have a radioactive particle that's going to have thousands and thousands, millions and millions of atoms in it, that every once in a while, it's predictable, one of those atoms decays. For instance, with carbon, it's carbon-14 decays to carbon-12. And we know the rate at which that happens. We've done lots of measurements. We know how frequently a carbon-14 atom decays to carbon-12. We have and the carbon-14 comes into our system from the atmosphere, from the carbon dioxide that the plants take in, and then we eat it as sugar, and the carbon-14 gets incorporated with other carbon into our system. So all of you are radioactive, by the way. Don't worry, it's so small, it's not a big deal. And so what we're able to calculate is carbon-14 has a half-life. If I started out with a ball that was complete carbon-14, in just over 5,000 years, half of that would have decayed to carbon-12. And then another 5,000 years, the half remaining would have halved again, so you'd only have a quarter of the carbon-14 left. And then it goes on and on. By the time you get to 10 half-lives, there's almost nothing left. So carbon-14's only good to about 50,000 plus years. So after that, there's not enough of it to measure. But uranium-235, its half-life is 4.5 billion years. Really, really slow, okay? But if you've got a lot of it, it's dangerous to hold in your hand. You wouldn't want to do that. So the major dates of millions and billions of years are coming from dating methods more like that, where their half-lives are much, much longer. For instance, the deposits for where human remains are found that are said to be a couple 100,000 or 1 million years old, those are using a radioactive element called potassium. So potassium has a radioactive element to it, and we can measure that, and that's also argon is another one used, has a much shorter half-life. Are they accurate? Sometimes yes, sometimes no. We have we have radioactively dated lava that's hardened from volcanic eruptions in Hawaii that we know exactly when that eruption took place in recent history. So it's not even 200 years old. And you can do a radioactive date on it, and you can get a couple million years as the date. So we have some of those anomalous dates that say sometimes it's not correct. But sometimes they can date something with different kinds of dating methods, and the date really coalesces to something that they expected, but it's coming from different methods. So they have a way of checking that. It's not just, oh, gives me the date I want, and this is what I'll use. So it's hard for me to say as a biologist, because this is getting into that physics, chemistry, geology stuff that just isn't that interesting to me. Inanimate matter doesn't move. I don't. So anyway, but so kind of a yes and no. I'm not giving you a direct answer because there's some uncertainty for me even in how to interpret radioactive dating methods. Quickly, the last question again was. Oh, the pre-humans. Yeah, what we find in the fossil record are apes and humans. We don't find true transitional forms of any kind, shape, or form. You may have heard of Lucy, which is an Australopithecine. Try saying that 3 times fast. And it supposedly lived about 3.5 to 2 million years ago. And that supposedly is the ancestor to Homo, to us. But there are at least 16 major skeletal changes that had to take place to get from Australopithecus to humans. And there's no record of that at all in the fossil record. It's this huge, as some would say, it's the human Big Bang. We got ape-like Australopithecines, and then suddenly you got humans. There are no intermediates. So I think there were a lot of weird-looking apes back a while ago. Some of them walked a little bit upright, but not like we do. But yeah, as I said, primarily what we find are fossils that are very human-like and those that are very ape-like.
We appreciate the question. Sorry, we didn't give a warning to you folks that we had to come to an end, but yeah, we have to end it. So if you have more questions, Ray probably needs a little break, probably needs some water, and feel free to come and talk to him afterwards, after second service and such, and talk to Sue as well. Okay, and there would be great resources. Let's close in prayer. Father, thank you for the wisdom that you have given Ray, Sue as well, and we thank you, Lord, for the good questions that were asked here. Thank you, Lord, that we have a mind that we can think and that we can reason, and that we can find out what is the most reasonable, logical answer to things. And we know, Lord, that it is always consistent with Scripture, and we thank you for that. Lord, bless our time as we go into our second service, and Lord, help us to have a worshipful heart towards you. In Christ's name, amen. Let's give Ray a great big hand. Thank you, Ray.